Good morning, everyone. Welcome to Compass Seminar on Friday. My name is Payson Tan, and I will be the host today. Well, as you can see, I'm underwater again because of climate change and sea level rise. But luckily, this will be our topic for today, and hopefully we will understand more about this through our presentation that will be given by Mr. Brian McNoldy. So Brian grew up in Southeast Pennsylvania, and his passion for weather was sparked at the age of 7 by the big northeastern snowstorm of February 1983, and then further peaked by Hurricane Gloria in September 1985. He earned his bachelor's degree in physics and astrophysics from Lycoming College in Williamsport, Pennsylvania in 1998, and then went on to graduate school, where he completed his master in atmospheric science at Colorado State University in 2001. He spent the next 10 years researching tropical cyclones at CSU Department of Atmospheric Science with Wayne Schubert and Mark DiMaria. He started in RSMAS in 2012 as a senior research associate in Sharon Majumdar School, and also now works in Dave Nolan's group and Renato Molina's group as well, working on a variety of hurricane-related topics ranging from modeling to facade communications. Brian has maintained a blog on tropical Atlantic activities since 1996, and then was selected as one of the 4 hurricane experts for New York Times blog from 2007 to 2010, and has been tropical weather expert for the Washington Post Capital Weather Game blog since 2012. His interest in sea level rise began early on upon moving to Miami, and has since been a consultant to local politicians, given lectures, and served on panels on the topic. So Brian, thank you so much for coming today, and the stage is yours.
All right, thank you for the introduction and for the opportunity. I'm going to share my screen now, if that's okay.
Sure.
Okay, is everyone seeing the slide? All right, thank you. So yeah, we're going to talk about a history and the future of what sea level might look like here around Virginia Key and Southeast Florida in general. As a super quick intro, this is a picture that I took just 4 years ago during a high tide. And you can see nice blue skies and calm water. There was no storm or no rain around. So that's part of what has already happened. So let's talk about, let's see, I must be on the wrong window. There we go. Oops, there we go. So we have a NOAA tide gauge right here on the Rosenstiel School campus at the end of the dock. It was installed in 1994, and we've had measurements consistently since then. For anyone who might be in attendance who's not from here or is new to the region, this is Virginia Key. Here you can see some of the other NOAA tide gauges scattered around. So we're a fairly representative of Southeast Florida gauge, and it just happens to be right here. Zooming in a bit, this is where the gauge is located relative to the Atlantic Ocean and Biscayne Bay. It's pretty exposed, not right on the ocean side, but certainly influenced. So here's what the history of the tide gauge measurements looks like going back to 1996. This is all the high tides each day. You can see I plotted in light blue is the high tide from each day, and then in the thick blue line is the 3-month running average, just to kind of get rid of the noise. And there's a few things that stick out. Of course, we have ups and downs each year. We'll talk about that later. But there's something else that jumps out. I marked some of these highest marks that have ever been observed. And turns out these were all associated with a hurricane, either that went by or passed close or something of the sort. Pretty widely scattered. But recently, we've had some high water marks that do compete pretty well with what the hurricanes did, and they were just high tides. We call them king tides, and I'll explain that a bit more later too. So big picture, what factors influence tides? I'm sure some of you are very well versed in this, but for anyone who's not, we'll just go over some of the big picture stuff. First, and most importantly, is the phase of the moon. New and full moons by far are what control the extent of our tides. Also, how close are we to the moon? Once a month, roughly, the moon is either closer to us or further away from us, so that plays a role. Another factor that's not quite as big, but how close are we to the sun, and that happens once a year, of course. And another thing that we'll talk about quite a bit later is this 18.6 year lunar nodal cycle. And this is a precession in the moon's plane relative to the Earth's plane. And like I said, we'll be talking about that in a bit more length shortly. So some non-astronomical things that influence our tides are wind, ocean temperature, atmospheric pressure, and the strength of the Florida current, which is basically the route of the Gulf Stream. So it's right off our east coast here. And all of those actually have an average or an average influence that is included in NOAA's tide predictions. But certain events, like the actual events going on right now in the atmosphere and the ocean are not included. So looking at these four, the wind, the temperature, the pressure, and the Florida current, I was playing around with this, and in a really simple way, I calculated a monthly mean of each going over a 30-year time period. I arranged them so that their contribution to sea level rise was a maximum of 1, and when they were at a minimum, I made it a 0. So those four, the sea surface temperature is the red one. It's its peak, well, right, around now, this in the summer and fall. It's at its warmest and at its coldest in the winter, of course. The surface pressure is in green, and that has a signal that looks like that, with the maximum contribution coming up this month. Our onshore winds are in the light blue, a little hard to see in there, but that's what those look like over the course of a year. And the Florida current on average has that sort of a contribution. And when you just simply average those four, no weighting attributed or no tricks, just an average of those four 0 to 1s, you get this dark, thick purple line. Okay, well, keep the shape of that in mind, because this is what the observed seasonal cycle looks like of our tide. So this isn't anything but what the normal tides vary by in the course of a year. So in general, we have the tides in the fall are about 10 inches higher than they are at the end of the winter. That's the normal seasonal cycle. And it just, from just a very simple treatment of those four ingredients, looks a whole lot like it. So we kind of know that they're important. I labeled on here what I alluded to before as the king tide season, and that's just when we have the highest tides of the year. And they're not always exactly on the same date or even in the same month. So I'm going to get into looking at tide predictions, because it turns out that plays a role in how we interpret some of the other long-term factors. So here's that first slide that I showed of the long-term time series of what our observed high tides were. Okay. This is something you can do. I mean, you can even do this in Excel. You can do this in any programming language you want, but you can do a Fourier decomposition of that up top and produce a list of components, which are called harmonic constituents, each with a phase, frequency, and amplitude. And you can add those all back up to create, so basically this is an example of it where you have one component, two components, three components, and you can add, 30 of those up or so, which is what we have here, to get the end result, which is just what our tides look like in the course of a year. And as I mentioned before, NOAA's tide predictions are not like what we think of as a forecast. They're just astronomy and climatology. They have no idea what's going on right now. So this is a simple plot of what the NOAA tide predictions would look like for us this year. And you can kind of see that hump up this time of year in the fall. You have the new and the full moons show up really nicely with those peaks. To this, I add about 5.5 inches to adjust to the more recent mean sea level, because as it turns out, NOAA uses a 1983 to 2001 mean sea level. And there's reasons for that. It actually goes back to that 18.6 year lunar cycle that I mentioned. So we're actually due for a new update to that. It just hasn't happened yet. But that's why it's old and happens to be about 19 years long. So as we see, the mean seasonal cycle peaks in mid-October, and usually our highest observed tide will occur on the new or the full moon closest to mid-October. So if we zoom in on, this is August 15th to December 15th, so we're just zooming in on that exact same plot. Let's see, it's a little slow, okay. So we just zoom in on that, and we can see the higher tides associated with the new moon. This is the one coming up in a few days. And then 2 weeks later, of course, full moon, new moon, full moon, so on. Just so happens that this year, the highest predicted tide is on November 5th, but it's a really close tie between quite a few days, including the ones around the October 6th new moon. So, I wouldn't focus too much on that exact day being the highest tide for sure. And again, I add the 5.5 inch mark to it. So the numbers that you're seeing on here won't agree with the NOAA tide predictions that you look up online. So a little bit more about this 18.6 year lunar nodal cycle, because it turns out that's fairly important. Over the course of 18.6 years, the moon's plane varies by plus and minus 5 degrees. And the plane precesses over a period of that 18.6 years. So this is not anything new. I'm not pretending that this is anything that I came up with. Turns out that people have been using this for over 5,000 years. Some of the old stone structures are perfectly aligned with this plus and minus 5 degree range that the moon has. And the first time you'll find it in a formal publication is from almost 300 years ago. So this is not a new thing. But the way that the planes come into alignment does have an impact on sea level, but it's not the same everywhere. In our area, it's about plus or minus 1 inch shown here. So we're kind of in the most rapid downward part right now, and we just had a peak about 4 years ago. Okay, so now that we understand some of those natural variations, we can get rid of those and look at the remaining trend. And this is what that looks like. This is what the mean sea level each year from 1994 to 2020 looks like. You can see it's not always up. I think that's an important point that we get asked a lot I think people assume that sea level rise is always up. overall, it absolutely is, as we can see here. But from year to year, not always the case. There can be reasons either in the ocean or in the atmosphere or a combination. Here we had 5 years in a row where the mean sea level went down. But that doesn't mean that the long-term trend is going down. The long-term trend is absolutely up. And our trend here is about 0.23 inches per year. And this is with the lunar nodal cycle removed. So in this example, I take what we know of the 18.6 year lunar cycle and what we know of our local sea level rise and plot them on top of each other. So the orange line is that 18.6 year lunar cycle, and the blue line is just our observed sea level rise, simply extrapolated into the future. It almost certainly won't stay that constant, but let's just work with that for now. The red line is when you add those two up. That's it. So here we are in 2021. We are currently in, like I said, just recently, we're currently in the most rapid downward part of this. And we will be in the most rapid upward part starting in probably, by the late 2020s, we'll start to see the effects of that. So what's important to note here, although that plus or minus 1 inch might not sound like a lot, it just so happens that here it matches the trend that we're seeing in sea level rise itself. So when we're in the most rapid upward part of it here, it roughly matches the rate of sea level rise, making sea level rise appear to be 2 times what it actually is. And then the part that we're in right now, for example, and will again in the future, it's almost the opposite sign. It is the opposite sign and almost the same amount. So it almost negates what we're seeing in sea level rise. So it's important to account for this. If you're looking at sea level rise over short time periods, you absolutely have to account for this or you're going to be off by a lot. Okay, so that's the observed water level. So that gets into this topic, which you'll hear referred to as 2 different things, either nuisance flooding or sunny day flooding. And on this chart, I plotted in 2 ways. This is the amount of time, number of hours that we spent above the mean higher high tide, which is that 1983 to 2001 average high tide. That's in the red. Or you can look at it in terms of the number of hours spent above what the National Weather Service considers to be our minor flood threshold, which is 1.3 feet above this one. So it's obviously not, we don't reach that as often, but it's still kind of a neat way to look at these 2. And so this goes back to 1996, and it's pretty easy to see a trend here. In fact, in the blue, number of hours spent above this minor flood threshold, we went years without it ever happening. And I point out here in 2019, 160 hours we spent above the minor flood threshold here. And I just superimposed the lunar nodal cycle here, not on any of these scales, but just to show you when it was high and when it was low and high. And so we're, the trend of these is not corresponding to the oscillation. They were really low back here when it was high also. So looking into the future, there's a lot of curves that are out there, and we don't know yet which one is going to be right. They depend on a lot of things and a lot of countries around the world doing certain things, and we just can't know that with an absolute certainty. So all these curves assume different things happening. I think and I think that others agree that the NOAA intermediate high seems to be a fair, a reasonably fair one to use. It's not overly aggressive, but our trends seem to be tracing it pretty well. So I'm going to base this example on the NOAA intermediate high curve here. From that, we would be seeing about an additional foot of sea level rise in the next 20 years here. So that takes us from this dot around 2020 up to this dot in 2040. In the next 50 years, so that brings us out to here, we could be seeing another 3 feet of sea level rise. And notice that that's not on the extreme end. That's kind of in the middle of the pack. Well, 3 feet's a lot around here, turns out. So what does it look like around here? Here are some examples I created for us. So here is Virginia Key with an additional 3 feet of sea level rise. So this is 50 years from now, what we might be looking at. Certainly presents some issues. We do have the large water treatment plant up here, which is built up. So even in 50 years, that does not show being submerged, which is good news. Of course, you might not be able to get to it, but anyway, that's that. Of course, the rest of the key is very low lying, including us down here in the corner. The road coming in here, you've probably noticed plenty of times. It looks like the ocean's ready to come up to it. Well, it will at some point. Not too far away, this is what Key Biscayne would look like with another 3 feet. Again, pretty significant problems there, including the road going into it. Just up north of us a little bit is Miami Beach, and I don't know if everyone appreciates this, but the side toward the ocean is actually the high part of Miami Beach. The west side is the low part, and that's you're probably aware of the road construction that's been going on the roads on the west side, West and Alton, and raising roads and installing pumps and all that. That's where that all happened and is happening. And then lastly, the last example was the Turkey Point nuclear power plant, which for those of you not from here or new here, that is only 23 miles from us. And with another 3 feet of sea level, I have not visited this site in person to know, how high it actually is. But according to this, it shows it basically still not being submerged completely. But again, serious issues of the operations of how do you get there? How does it cool? All of these straight lines are currently used to cool. You always have to have a lot of water around to keep a nuclear power plant cool. Those are all submerged. So I am not an expert at nuclear power plants, but that's probably a suboptimal place to put one. Okay, getting on to the last big topic. I wanted to leave a bunch of time for questions, but the last major topic I wanted to get to is hurricanes and storm surge. So what is storm surge? The rise in water level caused by a storm. Pretty simple. And it can be very rapid sometimes. You can gain feet and feet of water in a short amount of time. There's two reasons for storm surge. Most of it is the wind. Basically, it just can bulldoze the ocean onto the land. And a little bit of it is caused by just the low pressure itself. We don't tend to worry about that component much, but when you're dealing with a strong hurricane, that becomes a fairly significant part. Still less than the wind component, but it can be 1 or 2 feet just from that part. Storm surge is complicated, though. It's not as easy as saying we have a Category 2 hurricane coming, so here's what the storm surge is going to be. It depends a lot on the hurricane speed, the direction it's moving, the size of the storm, the intensity. as well as what the coastline looks like and the offshore bathymetry of what is it deep offshore or not, and so it's really a complicated thing, and unfortunately it's also really important. So looking at our hurricane history here, our campus here on Virginia Key was established in 1951. So we just missed Hurricane King, which was a Category 4 hurricane that passed right over. We got the eye wall passed right over us here in 1950. That would have not been a great start. So unlike the main campus, which UM started in 1925, and then we had the Great Miami Hurricane of 1926, our campus out here lucked out, and we were a year after a major hurricane. So yeah, we do have a long history of hurricanes here. But since 1951, there's actually a relatively small handful that likely created a storm surge of note. And these are the ones that I chose. I'm pretty confident that these are the ones that would be important for us since 1951. So we had Donna in 1960, which is this one, which, if you were here just 4 years ago, tracked both the track and the intensity were a lot like Irma was. So if you were here for that, you can pretend you were here for Donna too. A much weaker one, but more straight overhead, was Hurricane Cleo in 1964, and that's this one going straight south to north, and it passed right over us as a Category 2. Betsy in 1965 is this one that comes down here like this and crossed over the Keys as a Category 2, closest to us. Of course, 1992, we're getting more into the realm of what people would remember here. That had its closest approach to us. The center passed over Homestead as a Category 5. And then Irene, 1999, is this one. Doesn't look like a big deal as a Category 1 that crossed the state. The center didn't pass all that close to us. Turns out it actually produced a decent surge here. 6 years later, Hurricane Wilma made landfall in southwest Florida as a Category 3, crossed well to our north, but it was a very large storm and was moving pretty quickly too, and created a pretty noteworthy storm surge here. And the most recent one that created anything really worth mentioning was Irma in 2017, and I already pointed that one out. So those are the major ones in our history. So what do they look like? First, I'm going to introduce this other term called storm tide. Storm tide is actually what we observe. I mean, that's what floods things, not storm surge, because this is the regular astronomical tide plus storm surge. And why does that matter? Well, because if you have a storm surge arriving at low tide versus coming at high tide, around here, that's a difference of 2.2 feet. Other places it's more, other places it's less, but around here that makes a difference of 2.2 feet if a storm's highest surge arrives at low tide or high tide. So it really matters, and so that's why this is actually the quantity that matters to us, is how what is the actual observed level. So obviously we don't have a tide gauge going back to 1951, which is unfortunate, but it's the way it is. But with a bit of little bit of work going through some old papers and reports, we can create estimates for most. So I'm going to start out this sequence here with, here's a pole marking how high the storm tides will come. The 1983 to 2001 high tide that I've mentioned before, we'll reference that as 0 for the sake of this. Our more recent high tide I just picked 2018 to 2020, is almost a half a foot higher than that. So that's kind of our current high tide, we'll say. So here's a first ever sneak peek, I guess, at what I came up with for some of these hurricanes. I marked on here the 1.3 foot mark, which is what the National Weather Service uses for our minor flood threshold. We'll cross that several times a year just from high tides. Our highest king tide so far was 4 years ago. That was up here at a little over 2 feet. So I marked that on here as a reference point. So most of our high tides, our king tides, are kind of in this ballpark. That's been the highest, but they're usually in here in the 1.5 to 2 on this pole. And then here are those hurricanes. Turns out Irene and Wilma were essentially the same, really close anyway, 2.5 feet above this average high tide mark. I have a rough idea of what we had in 1960 from Donna. I put that at 3.4 feet with a large uncertainty around it. So that may or may not have been greater than 2017's, which we know exactly because we had a gauge. Moving on up, I have a fairly rough guess also for 1965's Hurricane Betsy. I put that at 4.9 feet and gave that about a foot of uncertainty. So kind of the 4.5 to 5.5, but certainly I'm more confident in that one than I am in Donna's. And we didn't have a tide gauge in 1992, but we had a lot of high water mark measurements taken around. And I'm with fairly low uncertainty, saying 5.4 feet for Hurricane Andrew. And although it missed us by a year, I'm going to put up what I think might be an estimate for Hurricane King in 1950. That would have been off the pole here by quite a bit, but my best guess is probably about 9 feet here above the average high tide. That one would have obviously been a problem. So this is what I'm kind of working with right now. This is a really interesting kind of side project that I've enjoyed looking into. And we actually, in recent weeks, gotten the Hurricane Center's storm surge unit pretty engaged in this, and they want to, when we're not in hurricane season and they have a little time, they want to kind of help out to maybe narrow some of this uncertainty down on these past storms. And since we've had the gauge, I just kind of plotted up, this is our mean high tide here in the red, and these are all the records each day of the year. Certainly gets quite full here in the fall. I've labeled some of the king tides of certain years. We have the 2020s, 15, 19, 17. But this is also now when we start to get some of these storms. And I talked about a few of them, the high ones like Irene, Wilma, or Irma. But some others have made their mark too, and they're actually, they hold the high record on certain days. We had Faye in 2008, we had Isaac in 2012, Dorian in 2019, Floyd in 99. Let's see, Wilma, there's Sandy in 2012, Mitch 98, and Ada in 2020 are some of the other ones I found that I would definitely not call king tides because we had a storm pretty close by. So that's that, and then I'm going to just bring up some final points here. So we know that we've had about a half a foot of sea level rise since the tide gauge was installed here about 27 years ago, which gives us an average rate of 0.23 inches per year. And we're looking at an additional 3 feet of sea level rise in the coming 50 years. We used to have these high water marks only be caused by hurricanes. Some are just happening with our high tides now. We know that there are some natural cycles that affect apparent sea level rise, but the actual sea level rise is continuing. And of course, we that's influenced by things on a much larger scale, like ice melt and thermal expansion of the oceans. I would say that that slide that I had about the what we currently are calling nuisance flooding, I would call it a slow motion crisis. It's one of those things that it's not as impactful to look at on the news of here comes a hurricane. Obviously that gets people's attention. This is going to impact every coastal city in the world, and there's not an obvious answer of how you escape it or do anything about it. Every city is going to have its own way of working with that. Hurricanes, low frequency, high impact events. They don't happen often, but when they happen, it's a big deal. And we have to plan and prepare for those as best as we can. And the two link up because as the sea rises, it just creates a higher baseline upon which storm surge acts. So what would have been you'll still have the same storm surge, but that the other term I mentioned, storm tide, instead of that being, let's say, 6 feet somewhere, you can add a foot or so, when just from that. So obviously that's a strong reason to consider both of these in concert. And I just wanted to bring up a link here that you're all welcome to use. This is updated each day with records and climatology and all sorts of. It has our, the highest tides, the lowest tides, and all that fun things with it. And that is where I'll wrap up and leave time for questions.
Thank you so much for the presentation, Brian. It was an amazing talk. Does anyone have any questions? And if you do, please unmute yourself and turn off your webcam and launch questions for our speaker, please.
I have a question.
Go ahead.
Hey, it's Dave Nolan. Brian, thanks. That was really helpful. I want to make one comment. During your talk, you mentioned that the regular NOAA tide predictions are only astronomy and climatology.
Yeah.
Right. But I don't think you meant to give the impression that they were not accurate. Like if you're using those to go fishing or go surfing, they're very useful.
Yeah, they aren't completely wrong. They're often low though. They're definitely biased low because they're using a mean sea level that's almost 6 inches out of date.
Right, but the general up and down, the timing of the high tides and so on is very accurate.
Yep.
Yeah. Okay. The question, so you showed those sea level, those inundation charts for the 3 feet. By any chance, did you make those for 1 foot?
I didn't, but I could.
Okay, well, you don't have to do it right now. But I think, for me personally, I guess selfishly, I may be working here in 20 years, and I don't think I'm going to be working here in 50 years. So I think a lot of us, for the same reason, would be interested in seeing that. Like, for example, is the causeway going to start getting flooded on some irregular basis, in 20 years?
I can't say for sure, but I'm going to casually say yes. I think it's likely.
There'll be some days where we got like an inch of seawater on the causeway. Probably.
Yeah. I think during the highest tides, by that time, they'll either have the road closed or you'll just have to drive super slow through a flooded road.
Well, I'll be coming to work in my jetpack, but some people will still be driving. So, other people feel free to speak up.
We have a question in the chat box from Chris Lancey. He says, great talk. The other hurricane in the 20th century that may have caused even considerable more surge for Virginia Key would have been the 1926 hurricane because it was a large Category 4 hurricane with the eye over downtown Miami. Any idea of the surge impact which might have occurred with that?
Oh, yeah, great, Chris. Thank you. That no, I didn't find a good estimate for that or come up with one yet, but absolutely. yeah, the Great Miami Hurricane of 26. It didn't earn that name for no reason. Yeah, that would be a really nice one to work up a surge ballpark for, though. Yeah, thank you.
And our audience, Maribeth, has one question. Please go ahead, Maribeth.
Brian, that was a great talk. I'm wondering about like from a mitigation adaptation side. So thinking about the plot that you showed of the tide, you know, just the general sine wave that you have, and then the sea level rise, and then when you add them together. So how do you think that that can be incorporated into a mitigation effort? Because I feel like the typical figures that you see with sea level rise are the ones that you showed for Miami with the different estimates, and it's kind of that like exponential curve. But I feel like what you showed about the lunar cycle playing a role is important, especially in the 5 to 10 year range. So how do you think that can be incorporated into mitigation efforts?
Yeah, that's really a good question. Let's just go back and forth between these two. So that 18.6 year cycle would just act on top of this, right? So let's just, to make it easy, think of it as a 20 year cycle. That you can just kind of put that on top of here, that you'll have the ups and downs. So it's not sea level rise itself, you know, it's just a natural oscillation that's up and down by the same amount every time. But it's acting on top of sea level rise. And I guess it's acting, so it might be acting on a scale that gives us a little time to make use of it, right? If we have 9 years when it's going to be kind of keeping sea level rise at bay, so to speak, you know, like what we're in right now, we're in this period where it's acting against it. This would be a good time to implement some of these major construction plans and all that. If it's a little late for that now, well, we're about to have the uphill climb where we're kind of at a ×2 phase. That's not going to be a great time to be doing anything because it's going to be getting worse in a hurry. But we can think ahead to the next one again, where it's kind of, you know, where we kind of hide the effects, I guess you'd say. So yeah, I guess, I don't know if that answers your question, but it would just be, you know, we absolutely know when these ups and downs are going to happen. So as far as how we act on that, I don't know. That's not anything I can do, I guess.
I saw Amy raise her hand. Amy, do you have any questions?
Yeah, hi, thanks, Brian. Question, actually, if you can go back to the last slide with the number of hours above flooding, or this slide's fine too.
I can go, yeah.
Yeah, so there was a lot of talk in the city in 2019 because of that big uptick, which produced, you know, water levels several feet above the actual Nile, the tidal predictions. And I'm just wondering if you've done any of the decomposition you did seasonally to see what were the regional factors that would have been playing a role there.
Yeah, I don't know. We had a kind of a mini conference, I guess you'd call it, at the end of 2019 here. There's probably quite a few people on this that attended that and gave little talks at it. It was a very informal thing where we just were trying to think of what's making 2019 so off the charts. And so I don't have any great answers yet. I mean, obviously it stands out because it's not going to be that high in 2021. It wasn't that high in 2020. So I'll let this, if anyone wants to jump in and help answer that of what was going on in 2019 to do that, please do so.
In our chat, Dr. Lisa Bill asked, is the 18.6-year cycle a common mode along U.S. East Coast, or are there large regional differences in its amplitude?
Yeah, there's a great paper on this that shows the amplitudes around the world. I think from 2011 or 12 or somewhere in that time frame. And it is an important contribution in the East Coast. I can hunt for that reference and send it to you if you want. It's really a neat thing. It's definitely not the same around the world.
Also from the chat, Molly Beringer, I hope I pronounced her name correctly. Please correct me if I don't. She asked, how much is subsidence or glacial rebound impacting sea level locally?
I don't think too much here. I know we have some vertical motion here, but I don't think it's a player that's on the same league as the other factors that we have. And again, if anyone, that is by far not my expertise. So if anyone has input on the glacial rebound and our local vertical motions, again, please feel free to help out.
Dr. Bill, I saw you raise your hand. Do you have any more questions for Brian?
Yeah, hi Brian. Hi everybody. Great talk. Thank you very much. Yeah, I had a question and actually a comment, I guess, related to the peaks in around the late 2010s. There was a really nice paper done by a couple of researchers across the street at NOAA AOML looking at the contribution of marine heat wave to those high sea levels. And so there's a thought that these kind of signals that are interannual in the ocean to do with changing heat content could be related to some of those elevated sea levels. And so I was wondering if, that's something you've looked into at all.
Yeah, thank you. That's, when I created that simple climatology of those four things and created that seasonal cycle, that was just using a sea surface temperature, which obviously is not the whole answer. You want it more of an ocean heat content concept. I don't have a long climatology of ocean heat content though. And if someone has one, I think that would be extremely useful for something like this. And if it exists, I'm sure it exists from someone here on Virginia Key. So the odds are good that this does have an answer. Yeah, thank you.
Yeah, these tools are coming into existence now with Argo, right? So after over the last 10, 15 years or so, we're now starting to get a pretty good handle on the upper 2,000 meter heat content changes.
Yeah, that'll be great.
David, I saw you raised your hand as well. Do you have questions for our speaker?
Yes, thank you, Brian, for a great talk. I just wanted to comment on the flooding predictions. Those assume stationary elevation, and I wondered for places like barrier islands whether you think that's a reasonable assumption in terms of sediment moving, especially when big storms come in. Do we have some feel on some of the consequences of big storms like Andrew? Did they really change elevation so far that it would affect the predictions of flooding?
No, these don't account for that at all. I mean, I suppose one could create something like that, like a what if such and such a hurricane came and moved, re-sculpted some of the barrier islands, but I don't know of anybody that has worked on that, like to create a hurricane that changes how high things are and all that, which certainly can happen. But no, I haven't looked at that at all.
All right, there are several questions coming from the chat. Chris Lancy asked, why is the IPCC median sea level projection about half of NOAA's intermediate projection?
I have no idea, Chris. That's a large difference between the two, and I would think that they'd be a little bit closer, because that's not necessarily the IPCC low. That's the median one. I don't have an explanation for why they're that much lower than NOAA. That's obviously a huge outcome if it ends up being just that versus the NOAA's intermediate high. I guess one minor point on this is these curves are tuned to us. This is from the Southeast Florida Regional Compact climate change. So it is more tuned to our region, but that is still over a factor of 2 difference. So yeah, it's a good question. I see. Oh, I see Arthur in the chat said, is NOAA regional and IPCC global? Yes. I just would not have thought that would make such a big difference, but perhaps it does.
In the chat, Arthur also asked, 2019 was an El Nino year. Does anyone know how ENSO is correlated with Miami sea level?
I do not. I haven't looked at that. No. Let's see. Weekly. Okay, so Molly, El Nino's weekly correlated with Florida current transport. Okay. Okay, so it does anti-correlated with sea level. Okay. All right. Thank you for that.
We have a few more questions from the chat. Keith asked, how much does subsidence or charges or changes in fresh water or water treatment flows affect this?
Can you repeat that? I didn't see that one.
I'm sorry. How much does subsidence or changes in fresh water or water treatment flows affect this?
I don't think it would be a large effect. Like I said, I know there's some vertical motion going on here, but it's not in the same league as the other things happening. That it would change our sea level rise that much. So in general, I don't think we need to account for that too much.
Thank you for the answer, Brian. One of our audience, Steve Kohler, asked, I've seen some researchers in South Carolina and New York using flood sensors to measure local nuisance flooding in coastal urban areas. Do you see any value in using sensors like this in Miami to fill in data gaps and supplement NOAA tide gauge measurements? Thank you for a fantastic presentation.
Oh yeah, thanks, Steve. That I don't know of anything like that going on, but it would be great because then you know what the tide gauge is recording every 6 minutes, and so if that can be associated with what areas flood, obviously that would be really helpful to know. If we're expecting a high tide in the next few days of such an amount. That you almost know exactly what areas are going to flood ahead of time and which ones won't. So it would be really helpful if they did that. Yeah.
Amy, I saw you also raised your hand. Do you have any more questions for our speaker?
Oops, sorry. I think I just forgot to lower it, but I'm following all the stuff in the chat, which is really interesting. About that 2019 event. There's a lot of local citizen science efforts going on through a program at FIU to do this flood monitoring through their sea level Eyes on the Rise program. And one of the things they said was in 2018, the king tides were like not very impressive. And then 2019 came along and everything changed. So I do think if we can provide some kind of guidance on that, even by doing what you did, Brian, just sort of like looking at all those 4 factors and including heat content, which is another good idea, and plotting them with time, at least we can have some hypotheses about why, including the Florida current, like Molly said, and maybe El Nino. It'd be interesting to put all those pieces together quantitatively. Thanks.
Yeah, thank you. I mean, I'm going to do a sneak peek here. There actually is, we're doing a little project on that here, on making a smart 1 week tide prediction, but more on that later.
Dr. Bill, please go ahead with further comment.
Yeah, hi again. Thanks, Payson, for giving me another chance to comment. I actually wanted to comment on some exciting news, I guess, that, well, definitely, that I just received funding from the National Science Foundation to explore ocean heat content and Florida current strength variability and their relationship to sea level. We're going to actually be looking at the relationship to sea level all the way across the straits, and of course at the coast in South Florida. So we're quite excited about that. So we're hoping to start pinning down some of this interannual variability that we believe is driven by the ocean.
Oh, wow. Excellent. Great.
Yeah. So Brian, would love to link up with, your think tank on sea level and learn from you guys and get some stuff going together.
Yeah, that sounds really interesting. It's I guess for those who don't know, the Florida current is measured right now by a cable basically running between the Bahamas and the West Palm Beach area. This is my understanding. I know there's people on the call that actually are involved in this. I'm not. This is my understanding of it. And when salt water flows across the cable, you get an electric signal back, and the strength of that changes the strength of the signal, and you can you can kind of deduce the strength of the current by that, and so it's a really neat way of measuring it, but it's measured at one place, like I said, kind of from the closest point between West Palm Beach and the far western Bahamas. But yeah, I know. Yeah, so I just saw your comment, Lisa, in there. Yeah, there's people here who are infinitely more informed about this than I am. But that's my quick version, I guess.
We also have questions coming from one of our audience, Mark Similian. Do you have any questions for our speaker?
Yes, thank you. And Brian and team, greetings from Miami Beach. Thank you so much for your insights and all of the useful information you've been providing to us. I actually have 2 questions, if I could. One, could you talk about the frequency and magnitude of major rain events, not hurricanes, but good old rain like we got yesterday, and how that sort of, adds into what we see in sea level rise and the real world impact that is having and could have?
Oh, yeah. Yeah, very good question, Mark, and thanks for being here. I haven't looked at rain, the heavy rainfall frequency. It's kind of obviously it's important, as it's related to sea level rise, and that if we're at a high tide, especially an exceptional high tide, there's nowhere for rainwater to drain. It just sits and adds to the problem that's already there. Rain itself doesn't influence sea level rise at all, but when we have these heavy rain events, kind of like a hurricane, though, it depends on if it's coming at high tide or at low tide, because if it's coming at a really high tide, like I said, rain doesn't have anywhere to drain. If it comes at a low tide in the non-king tide part of the year, you can certainly accommodate much more of a high rain rate. But yeah, I think it would be an interesting thing. I don't know, I can't do it, but if someone were to look at maybe a frequency of high rain rate events, because it's not really, it's a trickier question than just how much did it rain. It's a question of how quickly did it rain. That's what causes the flash flooding. So yeah, that would be a really neat thing to look into.
Thank you for that, Brian. That's helpful. If I could just ask the second question, and it may be a simple one, and you sort of touched on it throughout, but if you had to sort of boil down the essence of the threats that we face, how would you sort of summarize it, just so that I can make sure we're getting the absolute best takeaway from you?
Yeah, I guess that's an important thing to leave with. So they're two very different scales, right? We have sea level rise is just very gradually happening. It's not going to improve, but it's not also going to be incredibly worse next year or next week. Unlike a hurricane, where we could get a hurricane next week, and obviously that would be a huge impact on us very quickly. Hurricanes are a bit harder to prepare for, simply because of the scale. Some places, if you picture a 6-foot storm surge, that's close to impossible to actually prepare for, other than to just get out of its way. You're not going to stop that. So I think in terms of how we think of these things, I would certainly treat sea level rise as something that we have the advantage of time to think about and adapt to, or move away from, whatever the case may be. Hurricanes, though, that's a tricky one. There's only so much you can do with a major storm surge. If it's on that smaller end of storm surge, there's where you can be protected by walls and things like that. But they're very expensive, and then you have to weigh the cost of that is how much does it cost to have walls protecting all of Miami versus how much does it cost to occasionally have to repair yourself after a storm surge. So yeah, it's a tricky question between the two, because they're completely on the two ends of the spectrum. Of one's a constant and we know it's coming, one's a low frequency, high impact, like I said. So I don't know if that helps, but they're hard. It's kind of like an apples and oranges thing.
Yeah, no, it does help, Brian, and appreciate this presentation, all the good efforts from UM. I would just close with a comment. Miami Beach takes all this incredibly seriously. We have $1 billion plus program to address resiliency and flooding. And to the extent you and your colleagues have research opportunities, insights to share, we're open and grateful for it. Thank you very much.
Thank you, Mark.
Thank you for the question, Mark. Dr. Bill, do you have any questions or comment? Okay. So our time is basically running out, but if anyone has any more questions or comments, please send us an email that can be found on the website. Otherwise, thank you so much for coming here today. And last but not the least, happy Labor Day. Our next guest will be Dr. Johan Horstman, and he will be presenting his talk on next Wednesday at 3 p.m. Once again, thank you so much for coming and enjoy the holiday weekend.
Great. Thank you.